Hello, welcome and an excellent evening. Today we're looking at old and new power supplies, mainly for the Amiga 500, but similar things go for other computers like the C64, which has a whole bunch of different problems with especially the older power supplies. So when you get an old computer such as the A500, or maybe you still have one, sometimes you don't have the old power supply anymore, or it doesn't work anymore, and then you need a replacement. And you can mod the Amiga, for example, to take different voltages, like just 12 volts, and internally generate the necessary voltages, like the 5 volts and the minus 12 volts. But there are ready-made supplies like this one here from Electroware, which are newly made. They use standard power supplies made by Meanwell inside. They just give you a nice packaging basically with the cable, and there's also like a main cable here on the other end, and you have the typical Amiga style connectors on both of these. But the question is, of course, are these any good? Are these any good? The issue with these obviously is that they are at least 30 years old. This thing here says in particular made in West Germany, which means this is from before 1990. So it's at least 35 years old probably, maybe even a little bit older, who knows. And they will require servicing at some point or breakdown, and not everyone can service or repair switch mode power supplies, because that's what it is. It's actually pretty light, there's not much in here. It's roughly the same weight as the new one, I would say. But the question remains, what is the quality of these considering the output, namely the ripple that gets in from the switch mode power supply? And the ripple you can imagine like disturbance or noise in the actual direct current, which should just be a flat line, due to the way how these things work. For example, the old C64 Commodore power supplies would just use a transformer and a linear regulator, which would shed the excess voltage as heat, but produce a very stable output. We've taken a look at replacements for the linear regulators to get less heat, especially low noise ones, in a past video. So the question is, are these low noise? And does it matter? And how do they compare? And I'll show you how you can measure this with a little bit of equipment, because it's very hard to do the measurement with the Amiga itself, because the Amiga itself is a very noisy device that produces a lot of electromagnetic interference in the same frequency band as those switch mode power supplies actually operate. So we'll do something special there. I must say, this video, as usual, isn't sponsored. I bought this a couple of years back with my own money. Has been in use, this device, without any issues on my Amiga 500. And it doesn't see a lot of use. I think I use the C64 more often. But definitely has quite a couple of hours on it, I think, by watching demos, playing some games, etc. So I can say that it does work. Your mileage, of course, will vary. The pure specifications, and I'm gonna drop very carefully the plug here, are similar but not the same, because it is not the same inside. This here, for example, has 4.5 amperes on the 5 volt rail, 1 ampere on the 12 volt, and minus 12 has 0.1 amperes. Whereas this has 4 amperes only on the 5 volt, so half an amp less. 2 amps on the 12 volts, which is twice as much, and half an amp on the minus 12, which is also better, so to speak. However, the main rail that will be used on the Amiga will usually be the 5 volt rail, especially if you have a GoTech and don't use the floppy very much, and maybe you have an accelerator board, then you need a lot of power on the 5 volt rail. But I think that's enough talking. Let's take these to the bench and have a little look at how we can measure it. Okay, we are now at the bench, at my desk basically, with a little bit of clutter around here. Here is an Amiga 500 revision 5 mainboard, which is totally fine, perfectly working. You can hear probably the floppy drive ticking away. You can probably also hear the fan of the oscilloscope running, and I've put the DS remote view here, which is basically like a remote interface which is a bit slow but good enough for us to see something. But I try to filter out all the noises, but excuse me if that doesn't work quite well. And I've plugged in the original Commodore power supply just to check that we've got the right voltages. So here's ground on the board, trying to show it so that you can see it, and then there are 4 plugs here basically coming from, well, 4 pins coming from the sockets, and the first one here is 12 volts, 12.09, that looks perfectly fine. And then we have minus 12.1, also just fine, and we have 5.22 volts. This is a little bit high, but probably to be expected since the device was built for 220 volts mains, and currently we have probably somewhere between 230 to 240. So I guess this might be running a little bit high. And then the fourth might be shield, there's nothing on there. So 12 volt, minus 12 volt, and 5 volts. We're gonna check mostly the 5 volt and 12 volt rails, because the minus 12, I'm not even sure we need that. And for the Amiga Commodore supply, I don't have anything, but the Electroware uses this here, the RPT60 by Meanwhile, and they give, at least in their overview back here, it should be the RPT60B over here. It has 5 volts, 12 volts, and minus 12 volts, and on all of these it guarantees 80 millivolts peak-to-peak ripple and noise, or 100 millivolts peak-to-peak on the minus 12. So we will try to check the 5 and 12 volt rail. However, if we do that with the Amiga as a load, which is sensible because it is what you will be using, you will have a bit of an issue, because right now I'm gonna try and probe this with my passive probe here, and let's have a look at the 5 volts here, and that actually, yeah, here we go, looks absolutely horrendous. You can't see that, but on the display of the scope itself we're well beyond 100 millivolt peak to peak, and it looks extremely noisy. Same goes for the minus 12, if I can get it to properly come in, and also for the 12 volts. We are in AC coupling here, so we will only see the AC part, and that is, I think, good in this sense. But obviously this is extremely noisy, and I can't imagine that the power supply itself is that noisy, which is why we won't be using that actually. I'm gonna turn off the Amiga for a short while and put it aside even. We're not gonna use that, and instead we'll use this contraption, which I'm trying to bring in here without pulling everything down, and I already lost one cable. I've got myself one of the rare Amiga power supply sockets from the main board, which is, okay, I'll fix that in a minute, which is the square one, so we can plug in the power supply. I also got myself a 50 watt 22 ohms resistor, a 10 watt I think, maybe 20 watt, 4.7 ohm resistor, and a little LED in parallel with the 220 ohms resistor to load both the 5 volts and the 12 volts rail with like roughly 50% of the maximum amperage that the power supply could do. And I think that's a reasonable assumption for a stock Amiga. Maybe it's even a bit too high, because those were actually relatively power efficient, let's say. But if you would attach some additional devices, it might get to that. I think the 12-volt rail is pretty much overloaded compared to normal operation with the floppy mostly idling. But we get at least a certain load, because running these things without any load is not a good idea. I also attached something here, which I'll show you in a second. So, one more thing I want to show you is this thing here. This is basically just a coax cable, an RG58, 50 ohm impedance, with a matching Rigol inline 50 ohms terminator, which terminates this thing towards the shield or the ground with 50 ohms. On the other end, beneath the heat shrink, we have 950 ohms of resistance. And the shield wire is the white wire, the black one is the center wire, attached to the, let me see, I think that's a 5-volt line. Yeah, that's a 5-volt line. This, together with the 15 ohm resistor terminator, gives us a so-called Z0 probe, or a transmission line probe, which is supposedly better than using one of those passive probes with a large ground loop, etc. There are tons of videos by EEVblog and Element 14, etc. on how to build one of these. It's super simple. I measured the resistors, so I matched up a couple resistors to get exactly 950 ohms. So what we end up with is a 20x probe. This is a 10x probe, which attenuates the signal times 20. So I have to set my lower curve here, the blue one, accordingly. And let me quickly check. Yes, it is set to 20x. So I'll connect it up real quick again on my scope. And then I'm gonna set up this weird contraption here. Taking care not to have it running too long, because both those resistors will get extremely hot. They are rated for 50 watts and 10 or 20 watts respectively, and that is quite amount of power actually, and quite amount of heat that they will be putting out. So we'll just have it running for 2 or 3 minutes at most, give it some cooling time. In the meantime, I will tape down the power connector, because this is all a bit haphazard. So I'm gonna tape this to my desk and plug it in. And I'm gonna attach the probe to the 12-volt line, making sure that everything is neatly plugged in. So this should probably go somewhere here. This will probe the 12-volt line, and we're just gonna test how the ripple across this neat little resistor looks like. And there you can actually see something quite interesting. The 12-volt line is actually slightly noisy. I can read average of 20 millivolts, which is still pretty neat. And you can even see pretty much, let's see if I can make it trigger much better, because there will be some floating here. It's a bit unstable due to all kinds of interference I get. Well, good enough for now. So you see a little bit of ripple and ringing, which I think might be expected. But the 5-volt line especially looks very nice. It has very low ripple, average around 8 millivolts peak to peak, slight rippling. So it seems that this old switch mode power supply has extremely good filtering, and I'm feeling this is already getting very hot. So I'm going to turn it off. But yeah, it does look pretty decent. I would say this is definitely a good power supply. It is running a little bit high. You can't adjust it from the outside. You might need to open it up also for maintenance purposes, etc., which I wouldn't suggest anyone would do who doesn't have experience with maintenance of power supplies, obviously. That would not be a good idea. So next up, I think we can hook up the Electroware power supply. Oh, and by the way, the reason why we did this here is obviously because the resistive loads don't have any kind of ripple. They obviously are just resistive loads and don't introduce any noise. I should rather say noise, obviously, compared to the high frequency parts in the Amiga, all the chips, all the RF circuitry, whatever. So judging the power supply is a bit hard if you see a lot of noise from the device that you're actually powering. On the other hand, I'm not even sure if the ripple is that much of a problem if the whole machine introduces so much noise. But I'm not an electrical engineer. I've looked at a ton of videos now and asked some people who have a lot of knowledge in this regard, and try to build an experiment where we can safely judge the ripple that is coming out of these supplies, but I am not sure if it's actually an issue. In the past couple of years where I used the Electroware power supply, I didn't have any problems whatsoever with my Amiga 500, so from my limited observation it seems good enough, and the Amiga is still living, so yeah, I guess that's a good thing. And I personally have a little bit of a stomachache when using this 35-year-old power supply. If I could, I would probably do some kind of maintenance on that, but if I can get for, I don't know, 30, 40, 50 euros even, a good new modern power supply that can last the next 10 years and then I buy a new one, I think that's worth it. But of course, having a better power supply would be nice. But let's actually see what this thing here does. It has sufficiently cooled down. These are relatively cool to the touch now. And I'm gonna turn the plug, and immediately you can see they are high frequency components. Most of the noise is actually of the ripple is actually pretty low in both components, the 12 volt and the 5 volt. No, the 12 volt and the 5 volt. However, I can see the average on both is 77 millivolts. So that is within the spec that Electroware or Meanwell actually says it is. But it is definitely the case that the Electroware PSU has a much worse ripple than the old Commodore one, which probably is due to the fact that the output filtering of this new supply is much worse or cheaper than on the old Commodore, which is a bit surprising because Commodore was usually pretty much penny pinching. But yeah, it seems like the old power supply is actually better in terms of ripple and noise. As to whether that is actually an issue on the Amiga is a totally different question. As I said, as to my experience, I didn't have any issues with either of the power supplies, but your mileage may of course vary. Now I've turned off the power supply again because this is running hot. But that is mostly what I wanted to show you. It is important to have the correct setup. There are probably things that I could optimize. I'm still measuring the 12 volt line with the passive probe with a large ground loop which can act as an antenna. The Z0 probe could perhaps even be better attached or something, but it works reasonably well. However, I only have one 50 ohm inline resistor to terminate this thing, so I have only one probe. Otherwise I would have built a second probe because I have the other half of the RG58 cable still lying around. Obviously, because I cut it in half. And if you're interested in how to do this, you can check out EVBlock or some other like Element 14. They show you how to build one of these probes. But always be careful and think about what you're doing, not to short anything, not to measure too high voltage that you get shocked or zapped. We are working here on 12 and 5 volts. The switch mode power supplies are safely down there and I think that's okay. And they do have some protection circuit. If you do a short circuit, they will shut off automatically, but don't stress them too much. Also, as I said, these capacitors get really hot. Yeah, but this is a nice setup now. I can use this to test other kinds of power supplies, obviously, to load down at least 2 rails. I do have one more capacitor soldered in here, 1 watt for minus 12 volts, but I actually didn't care to load down that rail as well, and I don't think that it makes much of a difference. As we saw, the Meanwhile power supply is actually pretty much in spec. But that's it for today. I think we showed that you can use the old power supplies, and they do have pretty good quality. But as usual with 30 to 40-year-old equipment, I would suggest not to trust it blindly, especially don't let it run without supervision. If anything breaks down, the transistors inside or the caps, it might be a fire hazard or even risk of electric shock. So if you don't know exactly what you're doing, maybe a modern power supply might be a good idea, even if it has different electrical characteristics like the Ripple. But I think your life is probably much more worth than that of the computer. And if you're unsure, maybe you find someone in your community that can actually do service on switch mode power supplies, an electrician or something, that can make safe maintenance. But that's up to you, of course. I think I've been running very nicely on the Electroware power supplies. I know that in the community they are not without, let's say, problems. People say bad things and good things about these power supplies. My own experience is that they work absolutely fine on both my C64 and my Amiga. Don't have any issues whatsoever with those things, and I trust them definitely a bit more than 30 or 40-year-old power supplies. But that's it. Share, like and subscribe. Definitely leave a comment. I know that these topics are very polarizing, so I'd love to hear your opinions, and see you in the next video.